Today I would like to talk about one of the examples of using SAM SDK, which is like interfacing SAM with Microsoft Excel spreadsheet. I would like to give you a quick agenda, so I'll give a quick introduction to the concept itself. I'll explain the add-in structure then. I'll give some quick comparison how the simulation performs in native SAM SDK and how it works in Excel. I will give a quick example of how to send and return results from SAM SDK within Excel, and then I will try to demonstrate the final solution that we developed within our company and that we use it for our engineering purposes. Some conclusion and some quick ideas for future work. So, as all of you know, SAM desktop application is very powerful tool and one of the major simulation tools in industry. Some of you may know that the SAM also provides software development kit. Is a collection of different tools that helps you to bring all the functionality of SAM into your own applications. And this one particular is an example of usage of that SAM SDK by building an interface between SAM and Excel. So as it's shown on this diagram, in order to connect your Excel file with SAM library, you need to build add-in. If some of you may be familiar with development environment for to develop such add-ons, it could be done with the most generic ways, basically to create application using Excel SDK that could be downloaded on Microsoft website. Other options available online, you can download different libraries that help you speed up the process of developing add-ons. And it's not only about SAM, it's other libraries could be added in addition to the SAM to have extra functionality to your spreadsheet Excel. So, quick overview how exactly what's library of SAM library looks like. This is an example of one of the wrappers in SDK package tool. I think it's Python. So the main concept is SAM SDK has a variety of different modules for different applications. It could be for PV, CSP, wind, financial, battery storage. The main concept is you generating the list of parameters needed for any specific module. You run the module and you retrieve the results. So the goal was to come up with a list of parameters in Excel, send it to SAM library, and retrieve the results. So this example shows some generic, SAM API configuration. This is how it's going to look in Excel. So you, similar to, for instance, SDK tool that I'm going to present right now, you have different input parameters and you have output parameters for any specific module. It's like a variety of different modules. In Excel, you have to come up with a range of parameters, and that could be sent over to SAM library and retrieve back as data output the final results. I would like also to show quickly the real example in Excel. So for instance, this function over here gives you results of planar array irradiance for different configuration. I was using SAM PV-SAM module in SDK, not PV watts or any other different. So as I mentioned before, there is a list of required parameters in order to run the module, to execute the modules. I came up with those parameters, and you can see here the list, a few major parameters such as media file and system description translated to the function, and some variable parameters such as tilt angle, tracker mode, backtrack, and GCR can be used as additional parameters. So, for instance, with 25 degrees tilt angle, I'm receiving POA of 1902, and I see also that I will have some shading, and the shading is about 0.5%. The quick way to see the difference, for instance, is to change 25 to 30, and you see the calculated parameters over here. So as a result, so you can quickly basically copy and paste the function and see recalculated parameters in order to compare different results with the different tilt angles. You would see that your POA will decrease when your tilt angle of the system goes down. So that's sort of how the interface look like. You coming up with the input parameters. You using conventional Excel functions that you pre-build in SDK. You send those parameters in, and you after SAM executes the modules, it gives you back the results. You translate it back to your spreadsheet. So the following is basically I would like to demonstrate the tool that we developed within the company to use for design optimization and quick energy estimation. The reason why I choose to go this direction and coming up with a Excel spreadsheet is different. SAM is very powerful software, although it's very generic. It could be quickly used for rooftop, grid-connected systems, utility scale. Could be used for, especially with the most updated version, you can add battery storage, and there are so many functions that could be implemented. And this is good, and this is maybe not as good if you work with some specific applications on a daily basis. So I tried to develop functionality that needed exactly for specific application and use parameters that we use within the company. Also, the final results will be presented in Excel spreadsheet that could be sent to different departments. Nobody needs to install that software, or you can save time to generate a report and bring it back to Excel. So the following slides, and then maybe I will just show it in my Excel spreadsheet. First of all, you can specify the project location by entering the coordinates. You can quickly change the location for desired, or you can even upload KML file to give specific location of the site. Following, based on specified location, using weather file readable module from SAM SDK, this tool analyzes all the available data sources, weather data sources closer to the site location. It gives you the list of those meteor stations, or in this case, in Solar Prospector, is just the parcel where the site is located. It gives you a quick overview how far stations is from the site, what's the global horizontal irradiance on an annual basis, quick comparison, which meteor file gives you what data. Following this one is basically the system design is like one sheet, system description like dashboard. You know, for our specific engineering practices, we may not use all the modules that SAM allows in that database. We may use only a few module manufacturers. So I come up with most used modules database that could be used in energy estimation. So, for instance, from the previous page, we have a list of meteor files, meteor stations that are available for location. Let's say we'll go using the first meteor station, and right away I have my energy yield, performance ratio, NCF, specific production parameters. By changing different parameters, you can quickly see how it will affect the energy yields. For instance, if tilt angle was 30, we'll change it to 25. You'll see right away what's your impact on energy production. Also, another advantage of using this approach, that some of the functionality may not be presented in SAM, you can bring into your spreadsheet. For instance, the string sizing using the database of ASHRAE data, low temperature design data, it automatically can calculate what your maximum string size would be. As one of the macros in SAM available, I can also, besides the maximum open circuit voltage, I can quickly estimate what would be my actual string voltage and compare it with the MPPT range of the inverter. So it helps me to optimize my string sizing and see like what the most optimal solution. It's only a few parameters here that mostly used for energy estimation, and it gives me a very quick way of providing results to different departments. So just an example, I'll show you like the formulas here. It uses a function that was developed. It's called annual. It's really a user-defined function that you define in Microsoft Visual Studio. And it's very specific to your particular project. As output parameters, you see that in 1 second I gave all my 8760 results, which could be basically sent to the customer or a different department. Another thing, it shows the lifetime system production. As I believe right now, SAM, the most updated SAM version implemented this lifetime production capabilities. I was using the previous version of SAM, and what the tool does is basically takes into consideration module degradation and recalculates for every year. It reruns the same system design scenario and shows how different losses affects by model degradation. So if DC to FC ratio was pretty high, at the first year you will have a chunk of power energy that was clipped by inverter. With the consecutive years, your DC will go down, and you don't have that piece of loss anyway in the future. So that's sort of the idea. Especially, it's very noticeable if you will go with a very high DC-DC ratio, like 0.5. You can see the effect of this conventional way of applying just power factor, degradation factor over the 1 year and extending it over the lifetime of the system, versus nonlinear lifetime estimation. You can see the big drastic difference, which is basically could be included into financial model as well. Another most common output information is monthly 12/24 data, which is also quite easily to receive within a few seconds. So using this tools, it kind of gives you the flexibility of coming up with like custom functions. For instance, like this one is like parametric scenario. You can see the optimization of system of transposition factor. You will see different tilt angle or technologies like single axis tracker with backtracking or without backtracking. With at different GCRs, you sort of may have a sense how what would be the most optimized array orientation. Another example is with a given list of coordinates, you can quickly estimate what would be the system output for a particular location. You don't need to rerun, go back, and especially in PVSys, it's quite painful and quite time-demanding procedure to rerun the simulation every time. I would like also, to describe the minimum parameter lists, such as modules and inverters. You can basically, it's simple table. In this particular application, I'm using the method of 6 parameters datasheet for the modules. You can come up with a table of modules that used in projects and by using data available from manufacturer's datasheet. The similar approach could be used for inverters.
Thank you, Igor. This has been a very interesting demonstration of the use of SAM with Excel. I think we may need to move on to questions at this point. So if you have a couple of wrap-up remarks, that would be great, and then we'll start in on the questions.
Absolutely. Basically, I would like to express that since SAM is developing and has amazing update releases every few months, it's actually helps you to stay on top of the technologies and bring newer functionality with every release. That's probably I will wrap up, and I'm open for questions.
Great, thank you very much, Igor. Looks like we have a question.
Yes, we have. Is there a way to integrate shading profiles with this method?
Shading profiles, it's definitely row-to-row shading or self-shading is part of the PVSAM module, and it's incorporated into this method already. Regarding the 3D shading of other obstacles. I believe SAM is going to come up with a new shading method in recent future as a pre-calculated database of shading impact. And my plan is add this functionality as soon as SAM as soon as you guys from Unreal add this feature.
Please feel free to type them into the chat box.
In the meantime, Igor, can you comment on approximately how much time dedication was put into something like this as far as integrating it with SAM? If that was one of the harder parts or if it was getting all of the rest of the interface going?
It's really it's not as time demanding, especially if dedicated software engineer would be working and not solar engineer would be working on this tool. It's quite simple. It depends. I think the major concern is the Excel SDK. That it's sort of like assembler language if you compare it with assembler versus C++. So there are a variety of add-on libraries that could be used to help avoid this quite complicated interface of Microsoft Excel. I'll just quick an example, for instance, just a snapshot of Visual C++. One of the functions that I was using, like PV annual, it's basically looks very similar to any SAM SDK wrap, and it's just some description of how communication between admin and SAM is presented here, and everything else is pure C interface that's available in SAM SDK user guide.